newscaster. The weather today will be sunny and warm, about 73 degrees. All right, welcome. You have to listen to my old fogey music if you come to my class. Sorry. I like the older music. Okay, I'm Dr. DeShavo. I'm going to be teaching pathophysiology this semester to you. Welcome. I know that there were some volume problems. That's why I had that up so high, because we're going to be watching some videos. So for the people at home from now on, what I'll do is when I play those videos, I'm going to zoom you in on the screen, on the PowerPoint, okay? And then hopefully the volume's at a better level for those videos. Now, of course, the songs are just my silly little way to sort of break things up a little bit. The videos that I have interspersed into, I'm going to bring my people at home in closer, there we go. Okay, you can see I have links there. If you have the PowerPoint filling your whole screen, you could come and click right on it, okay? So, my David Bowie song, of course, is just fine. The cell song is fun too, but it's going to help us to look at the different parts of the cell. Okay, so as you go through these PowerPoints, these are going to be the important ones, okay, the educational ones. Now, I was hoping to sort of walk you through this movie, Wit, during this class. We aren't going to have time, okay? But if you ever get a chance, please rent the movie with Emma Thompson. It's about a woman who's been diagnosed with cancer and her journey through that. It's pretty powerful stuff. And I think there's a lot as healthcare providers that we can appreciate from that. So that's what that's about. And I haven't taken it off the PowerPoint yet. So you're welcome to click on those links, but there was so much more material in this class than I ever anticipated. We ran out of time, didn't have time to do those, okay? So let's look at the syllabus first. I'm going to bring my people at home out so you can see me. It's no big deal. We're going to look at the syllabus. The syllabus is under the learning modules, and I'll zip you through how to use the website really quickly, even though I've already given you instructions, okay? And the syllabus is pretty straightforward as well. So let's go through the basics. My name, of course, I went over. My office is in Donovan GB246. It's in the basement. If you go into that building and you go in the basement, I'm near the snack bar. It's basically one big circle. If you keep going until you see the snack bar, my office is right across from the snack bar. And I always have something decorative on my door. Right now I have like flowers, or I'll have a wreath as we get into fall, so you know it's my office. It catches the eye. We're going to keep it really simple with grading, okay? We're going to have 3 exams. They're each 75 points, your multiple choice, your matching, your true false. And then we're going to have a various amount of quizzes. I'm not going to commit to the amount yet, okay? Because I'm still prepping this course. This is only the second time that I've taught it, okay? So we have, I forget how many we have. We have one about per chapter. So that way I'm getting you to study as we go. Now, the quizzes are open book. You need to open I had one poor woman trying to do them with a closed book last semester, and she was emailing me and finally hit me, and I emailed her back and I said, you realize these are open book, right? I mean, they're too hard to take without your book open. You need to open your book, okay? But I do that on purpose to get you to study. Okay, and it's very helpful for your exams to do well on those quizzes, okay? So we're going to keep it really simple, keep it to a various amount. There may be more, there may be less than 75 points, okay? Because I want to do one per chapter for you to keep you up with that. But you will have 3 exams. So we are on, so it'll be week, we'll probably do week, I need to relook at it, week 4 or week 5 for the first exam. And then week like 8, 9, or 10-ish for the second, okay? And we'll talk about that as we get closer. And then your final will be during finals week, okay? Any questions on that? Okay. Those exams you will take at home, they are timed, okay? Because we don't have enough time to take them here. If you're really nervous about taking them online, come see me. We could set up a time to meet together. I think you'll be fine once you take the quizzes, okay? The only thing about the quizzes and the tests, if you do not maximize your screen, the timer covers the questions. Okay, people had a problem with that last semester. And you all know how to maximize your screen, right? You hit the box in the upper right-hand corner, okay? So please maximize your screen so the timer's out of the way, okay? I had one poor student was in the way the whole time, and it really was distracting. So I want to make sure that you understand that. Once you start the exam, you need to finish, not the quizzes. You can go through the quizzes as slowly as you want to. You could go back and review them, okay? They're just open. The exams, though, are timed. You have 90 minutes, and you cannot backtrack, okay? So once you finish a question, you have to move on to the next one. You can't get back to it, okay? So grading scale, you could read through that. Now let's talk about the texts. I prepared this course with this pathophysiology book by Nowak and Hanford, I believe. Okay. I like it because it's a little more to the point than other pathophysiology books that I've looked at. In order for us to get through some of the other pathophysiology books, we would need a good 2 to 3 semesters. It's a lot. I mean, they're 1,400 pages. So I like this book because it's smaller. I prepared the course and then they told me it's going out of print. So here's the thing. You can find it online, used versions if you want it, okay? And it'll be a little bit cheaper. A lot of my students during the summer were okay without it, okay? I take my test questions from my lectures. So it's up to you. If you sit through 1 or 2 lectures and you feel okay with it, I think you'll be fine without the book. It's up to you. I found mine online for like $5. So whatever you think. Now, that being said, I have an old edition I'm going to put in the library for you guys on reserve. So you can take it out for 2 hours at a time. So there's a couple different options with the book, okay? I put 2 review books in the bookstore. I think that they'll be good. They don't directly correlate with this class. They are a supplemental, okay? I really like the portable pathophysiology. I think that that would be a great thing for you to have should you have somebody come in with some odd disease process that you're not familiar with, you know, this kind of thing, okay? It's really great. It's got great pictures. It's got great summaries. It's got great explanations, okay? It doesn't correlate with the class, though. It's a supplement. Now, the other supplement, that's up to you. Go in and look. People have told me it's helpful with boards, okay? So let me know what you think about that second supplement, okay? And once again, it won't directly correlate with what we're doing. It'll be a supplement. So if you really need that book that correlates with what I'm doing, you'll have to find that Nowak book. Yep, that one. Yep. That one I'm kind of iffy on. I'd like feedback on that one. I sort of chose it as a supplement. I got to tell you, I'm a little iffy. So I would like feedback on how you think if that helps or not, okay? When it comes to the first like 4 weeks, a lot of it's going to be cellular, okay? That book, those books don't cover what I'm going to be covering the first 4 weeks. What will help you as a supplement are the anatomy and physiology lectures and PowerPoints that I've posted for you, okay? So I think that, you know, that covers the books. Excuse me. So, prereqs, we don't have to worry about that. Examination, we talked about that. You know, I really, guys, I don't care about your cell phones. We all have stuff going on, right? We have kids, we have jobs, we have stuff, we have emergencies. So it rings, you know, please turn the ringers off. It rings, you got to talk to somebody, just go ahead on out. You could go to the bathroom whenever you want to. Actually, I had a student ask me in my AP course, can I go to the restroom? They just got out. God bless them, from high school. Okay, so anybody have accommodations, please come see me, okay? There's no attendance policy. It's, you know, at this, I'm going to change that in the next semester, but as of right now, you guys are on your own, okay? Now, I think that mostly covers everything in the syllabus. Are there any questions about the syllabus? Okay. Pretty straightforward. Let's look at the online stuff quick. Do you guys have any specific questions about the online stuff? My people at home, I'm going to bring you in closer. Okay. So basically what you need to worry about with the online stuff is, if you come home, when you open your account, okay, you'll see your class over here. You'll click on it. Oh, but this is where the email is, isn't it? Okay, so check your email because I'll be sending out weekly emails, if not more. Come into your class, click on it. Everything else other than the emails, I put totally under learning modules. Okay, so you'll come in for, and I'm going to change this as we're going along too. I'm going to change this to say week 1, chapter 1. So you'll know week 1, we're doing chapter 1 because it's consecutive for the first 4 weeks and then it changes, okay? So I'll change this maybe starting tonight or the next night. Let me write myself a note. Does everybody have a syllabus? I hope. Good. Okay, so we'll add that in there. So it says week 1, and all you do is you come into week 1. do. Okay. Here is PPTX is the PowerPoints. So here's the same exact PowerPoints that I'll be lecturing about today. Here's A&P chapter 1. After my A&P lectures, I put whether I not require it, but suggest it strongly. This is not a requirement though. Okay, this is directional terminology. If you want to review it, help yourself. I had a lot of my summer students ask me to upload all of my A&P lectures, so I put a bunch of them online for them. Now this, I think, the cell would be extremely helpful. Hopefully you guys watched it. Okay, so here's the lecture for A&P cell. Here's the PowerPoint. Here's the lecture, here's the PowerPoint, okay? Any questions about that? And you can see I have video lecture, PowerPoints. I don't have PowerPoints on that first one, sorry. I can't seem to change it for some reason. There's something weird going on with Angel. Just like I uploaded the new syllabus and it wouldn't link it anymore. I don't know. Anyway, keep my mouth shut. You know, it has something nice to say, right? Here's the in-class video lecture, which I'm going to change, okay? We'll upload that, and it's huge. And then here's the second part, which I'll upload the second part as well. And then there's your quiz, okay? Which I'm not sure if I've opened the quizzes, but I shall do so tonight. I think they're open though, okay? So, you know, for week 1, boom, that's what you have to do. Just go right through the material, okay? Does that make sense? Yeah. Now, are there any questions about the angel part of it? Okay. No, because what I would like to show you now is I'm also right now, that's weird, streaming. So if you go, and I just emailed you the directions how to do it. So you get up late, you overslept your alarm, haha, right? Probably nobody does that in here, I would guess. Okay, you've overslept your alarm, you're not going to make it. Go on to Ustream. Go to the website. I emailed you these directions once again. You go to search for channels and videos, and you type in MEGKOZE, enter or search.
How many people there might be.
Click here, A&P lecture. Sorry, it's so loud. I'll turn it off in just a second. And hopefully this is me. Did you hear that? Listen. I'm just going to go on forever. That's so cool. That's enough of that. Let's go for 3 seconds. Okay. So hopefully it's not doing that for my people who are streaming at home, and it's just doing that here because I'm here. Because that would be a little strange. Okay. So yes.
MEGKOZE.
Yeah, it's my maiden name, and I should have put my real name, which now I'm afraid to change it because people are already looking to stream it. So it's going to be Megkoze. But I did give you those directions in the email this morning. Okay. Yeah, I just emailed them because I had a couple of people asking about streaming. So you guys are welcome to stream from home. People are watching the videos on their iPhones. Okay. From now on, I'm going to either do this screen or I'm going to zoom you in on the PowerPoints. I think it'll be much easier to see than doing that wider view. So I think it'll move much smoother from here. Okay. So we hit Ustream, we hit Angel, and we hit the syllabus. We talked about the books. Are there any questions about any of that? Oh, okay, cool. So what I'm going to ask of you guys is if you could try, unless it's a question that is building on the material while I'm lecturing, if we could keep questions and comments for the break. So that way we're keeping the lecture a little less disjointed. But of course, if it's something that you need to understand the next bit of material, stop me, okay? If you are going to ask a question, there are microphones in front of you. If you could click them on so the people at home could hear you, and then click it off after you're done if you have a question, okay? So we'll take a break in like 45 minutes-ish. If you could write your questions down, okay? And then I'll answer questions then. It'll make the lectures move. Oh, somebody turned on their mic, didn't they? Do you see the camera? The camera moves when you turn your mic. Yeah, don't turn the mics on now. Does everybody have their mics off? Yeah, okay. Yeah, we're watching you. The cameras will move when you turn your, go ahead, turn your mic on. See, isn't that cool? So, and you could turn it off now, thanks. Because we'll get feedback if you leave your mic on, okay? We'll fine. So, but I won't be taping during the breaks. I'm going to stop it so we have shorter videos, okay? Are we ready to start? Yeah, cool. Okay, so let's see here. So, do you guys have a question? Did I hear? No, okay. Changes. Okay, so silly little video, but it actually has a lot of good information. I'm going to play it. It's going to be a little bit loud for you guys, which will wake you up, but also I'm hoping that people at home will be able to hear it well. If you can't hear it at home, good morning. Good morning. Can we make room for our new person? I don't know where you like to sit. You're welcome to sit up front. You're welcome to sit wherever you like. Okay. When we're watching the videos from now on, I'm going to zoom people in on the screen. So let me go ahead and do that. Okay. So silly stuff, but there's some good stuff to learn from this. And then I'm going to go over parts of the cell. Are we ready? Okay. Can somebody hit the lights for me? Hit it. I think there's a, yeah.
I went into a cell to get out of the rain. And there was the gatekeeper, the cell membrane. I went into a cell, and what did I see? The mitochondria, it's the energy factory. I went into a cell and said, who drives this bus? And found myself talking to the boss, the Nucleus. I went into a cell to recover from a spasm and found myself swimming in some clear cytoplasm. I went into the nucleus to ask how to get home, and got genetic info stored in a chromosome. I went into a cell, and stretching oh so far was a thin and wavy network. It's called the ER. I went into a cell trying not to be perplexed by the packaging and sorting in the Golgi complex. I went into a cell and said, who makes proteins here? And somebody responded, it's the ribosome, my dear. I went into a cell and was feeling pretty fine till a lysosome engulfed me and dissolved me in enzymes. I went into a cell and was feeling pretty nimble, till a centriole lassoed me, tying me up in a spindle. I went into a plant cell to see how trees get so tall, and all around the outside was a rigid cell wall. I went into a plant cell, why is it so green, I asked, 'cause I make food from sunlight, said a green chloroplast. I went into a plant cell to see how plant cells store food, when a vacuole informed me that he was the storage dude.
And don't worry about the plant cells.
So when you go inside a cell, remember what you see. There's over 1 trillion cells in both you and me. Just sing this song if you ever feel confusion. And remember, active transport is the opposite of diffusion.
I could be that talented. You know, I was sort of singing to David Bowie as that song was playing, so I apologize for my people at home because it ain't pretty when I sing. So, okay, so different parts of this cell. So I'm going to go a little bit off notes here. Okay, you have to take some notes with this part. Can you flip on the lights for me? In that song, I'm just using as a real general introduction. Anything that I test you on will be directly from my lectures or from the notes, okay? But it's important for us to understand cells, how they are structured and how they interact to understand pathophysiology, because guess where everything happens? At a cellular level. As much as it makes our skin crawl, okay, that's where it all starts. So I'm going to give you the real basics. You couldn't get that down? The thing isn't working? Okay. I'm going to give you the real basics of what I think you'll need to understand for cells, okay? And there'll be some additional things as well. So this is just simply what we call a composite cell. Some of it should ring a bell. How long has it been since we've taken biology or A&P? Okay, never mind. Don't worry about it. Your secrets are safe with me, okay? So, of course, this is going to be what's called the cell membrane, also known as the plasma membrane. You know, I won't get into like which is called what, you know, I want you to understand the cell membrane as a general structure. Now, the cell membrane has something in it called phospholipids. This is what you need to know from that, is that you've got fatty membranes encasing the majority of the cell. Okay, you've got fatty membranes encasing the majority of the cell with phosphorus on the ends. So what that does is that fatty membrane helps to make that cell very selective. And let me tell you how, okay? Fatty substances or small substances can sneak right over that membrane, but the majority of substance has to pass through channels. So interspersed through this cell membrane, you know, are hundreds, if not thousands, of what are called protein channels, okay? So what happens then is the cell can say, okay, I need some more glucose, or I need more proteins. And it can selectively decide and accept things through those channels. Or that cell can deposit its wastes and excrete them through those channels. Well, not often, actually goes through the cell membrane. But substances can come through those channels, okay? So this gives the cell the opportunity to be what we call semi-permeable. Doesn't want to let everything in, doesn't want to let everything out. Because let me tell you the other thing about cells, guys, is they like to be a certain size and shape. Great example is red blood cells. What are red blood cells shaped like? Thank you. None of my freshman students know what a Werther candy is. I can't believe it. You know, I'm going to bring a bag of Werther candies in to my class. They're shaped just like a Werther's candy. So what that means, I see some people are not sure what that looks like. A Werther's candy, I'll bring a bag in here. If you're looking at it straight on, okay, it's not a nucleus, it's a little divot. So if I take this and turn it on its side, it's gonna look somewhat like this, okay? Because red blood cells are anucleate, which means what? A means no or without, okay? So these red blood cells like to be a certain shape and size, don't they? They have a semi-permeable membrane that will allow the proper amount of substances in and out. Now, suppose that we immerse that red blood cell in a solution that's not isotonic or the same as our body's tonicity or solution, it can start to change size. If these red blood cells change size, do they function properly? Absolutely not. They can't make their way through our bloodstream properly and slide across each other and slide through our blood vessels, okay? So all of the cells of our body, just as one example, this is just one example, need to be a certain size. So think for just a second, if these cells were not semi-permeable and they started to let a lot of sodium into them, what happens when we let a lot of sodium into us? Is anybody Russian here? I'm Russian. You ever had, nobody? Okay. Well, Russian dinners are full of salt, okay? You've got the fish, right? Okay, so you eat those, you ingest a lot of salt. What happens to your body? Where salt goes, water goes, and you swell up, okay? If these cells were not semi-permeable, just one example, if you let too much sodium in, what's going to happen in those cells? They'll start to expand. They can only expand so long before they lyse or they break, okay? So that cell membrane, it's really important to understand that it's semi-permeable. It's important to understand that it has protein channels, which is very selective about what it will let in and out. That's very applicable too when you get into pharmacology, okay? Because there are receptors on certain cells that will let substances in that are not on other cells. That's why if you give somebody thyroid medication, it only affects their thyroid, okay, etc. It's because of these receptors, okay? So that's an important general introduction. Now, what's the centerpiece here? The nucleus. What does the nucleus do? What does it hold, first of all? Holds DNA, excellent, okay? So DNA is going to be in the center. And what does DNA do for us? It gives us our code. Yes, our genetic code. Okay, DNA gives us our genetic code. And the genetic code is what makes us us, right? Okay, determines how tall we grow, our eye color, our hair color, our personality, okay? So DNA is going to have our genetic code. What's the other thing that DNA does, though? What is the other thing that DNA does?
Dictates the process of what the cell does.
It dictates the process of what the cell does, okay? And how it does that is it helps to code for the creation of proteins, okay? Helps to code for the creation of proteins. So, let me just do something really quick here. Carbs, lipids, and I did this on the lecture, and proteins are our macronutrients. So we have our meal, it's going to be comprised of carb, lipids, and proteins, and also vitamins and minerals. Those are called micronutrients simply because they're what? Smaller, right? In smaller amounts, and our macronutrients are going to form the bulk of our food. Really quickly, I just like to go over what they do. So carbs give us our energy, okay? You do other things too, but these are general descriptions. So lipids are going to be the second form of energy. It does some hormones, and it cushions, right? Cushions organs, cushions us, helps to provide warmth for us, okay? And what do proteins do? So what is this little DNA help to code for? It helps to code for proteins. Well, why are we making proteins? What do proteins make up? Everything, right? Proteins are going to form the bulk of the structures of our bodies, okay? Enzymes and hormones. So our DNA is going to help to determine those structural components, okay? So proteins, structure, enzymes, and also some hormones, okay? So DNA holds our genetic code, but it also helps to create proteins, which will help to form the structures of our body, okay? So it kind of has a dual purpose. So DNA will send a message out into the cytoplasm. And the cytoplasm, we remember that, right? Cytoplasm is just going to be, it goes between a liquid and a gel. And it's the cushion, it's the gunk in which all of the organs of a cell live, okay? So DNA is going to send a message out into the cytoplasm to RNA. Well, actually, RNA is going to take it out, I should say. And we create proteins, okay? So, I don't know. Well, let's go over really quickly. There's structures in here called the endoplasmic reticulum. I don't think you're going to need to know that. What I do want to talk to you about, though, is there's little kidney bean shaped, and if we have to learn about that, we'll learn about it in the future when it's more applicable. I want to talk to you about mitochondria. Okay, mitochondria are little kidney bean shaped organelles or tiny little organs that live inside of a cell that create our energy. Okay, so do we understand the whole process? Do you guys, okay, I'm going to make your skin crawl. Did you guys ever study the Krebs cycle? Yeah, right, okay. I literally, in my biochem final, broke out in hives. So anyway, Krebs cycle is that complex cycle where we take what two substances to make energy? Well, ATP is the energy that we make, sugar, glucose specifically, and oxygen. Good. Okay, so glucose and oxygen, we put together, we put it into the mitochondria, and we come out with ATP. Okay? And that ATP, so in the mitochondria, glucose and oxygen will eventually, through multiple very confusing steps, make ATP, which is our energy packets. Okay, can we make energy without glucose and oxygen? Yeah, actually we can. It's not as efficient. Okay, and that's anaerobic respiration. But we're not going to, don't worry, we're not going to get into it. Okay, so basic structures of the cell. Are you with me? Okay, good. Any questions? No? Okay. So causes of cell injury, because of course, if we're talking about pathophysiology, we're going to be talking about the damage of our function, right? How our body is not functioning properly. Are there many disease processes? You betcha. Okay, and they're all complex. So what I want to try to do is try to give you an underlying understanding of how damage can affect these cells and what their responses are, okay? So deficiency, intoxication, which doesn't mean alcoholism, it means toxic substances. Well, it could mean alcoholism, okay? Toxic substances and also direct trauma are going to be three major ways that we can damage those cells. Okay, so let's go over some of those and then we're going to practice some examples. Okay. So deficiency is pretty straightforward. Lack of supply of nutrients, lack of supply of oxygen. How are we going to cut off the supply of oxygen to a tissue? What would be an example? Very simple example. A friend of mine that I just, if any of you saw me talking to my friend in the hallway, his father just went through one. Heart attack. Okay, if you have a heart attack, you have some sort of blockage, okay, that is not letting the blood get to the tissue beyond. Tissue needs a constant supply of, well, it depends on the tissue. I take that back. Okay. Very active tissues, very metabolically active tissues need a constant supply of oxygen, or those cells will start to die. And as those cells start to die, guess what starts to happen to the cell membrane? Breaks apart. If that cell membrane breaks apart, substances start to leak in, and substances also start to leak out. This is why when you test blood of people who are having a heart attack, you find what? Creatine phosphokinase, you're going to find troponin, right? Because you start to get the substances that are normally within those cells leaking out because that plasma membrane is getting destroyed, okay? Because it's not getting the nutrients it needs to help facilitate its renewal and its existence, okay? Does that make sense? So deficiency and nutrients. So maybe primary, you're just not getting enough either oxygen or food, okay? It may be secondary. What's going to be a secondary example where somebody is not getting the nutrients that they want? This is the only bad thing about taping the classes ahead is all these answers are on the videos. Here you go. Celiac disease. What would be another one? I'm thinking of one right now. The back clapping.
I'm just thinking
Cystic fibrosis, okay, would be another. That's one of their primary problems. Do we understand that mechanism? Okay, some I think are looking yes, some are thinking no. So cystic fibrosis is an overproduction of mucus. That's where the back clapping comes in because you're trying to expel that mucus for them, right? The other area that gets blocked with mucus is their duct that comes from their pancreas that supplies digestive enzymes. Did you guys know that? That your pancreas, I'm seeing some yeses and some nos. Your pancreas we think of as regulating what? Insulin, right? And also glucagon, right? Okay. But it also releases digestive enzymes. The release of insulin and glucagon is only about 10% of the pancreas, anatomy speaking. The rest of it is all devoted to secreting digestive enzymes. So what happens, it's so sad, with people with cystic fibrosis is they get a blockage of that duct with mucus, and the digestive enzymes cannot make it into the duodenum. If you don't remember that anatomy, please go check it. Okay, so you can't release that. If you don't break down the food stuff, you can't absorb it, and they get thinner and thinner and thinner. Okay, so that is going to be, you know, a secondary cause of a deficiency. There's an underlying pathology that's going to affect them. Okay. I'm going to use pathology and pathophysiology kind of comes out interchangeable for me. A lot of people think, just so you know, pathology is more being like in the hospital. You know, you have a disease process, you biopsy, you send it to the pathologist. People think of pathophysiology as being, you know, the study of it. I'm going to kind of switch back and forth, okay? So viruses can also destroy normal cell functions as well as causing deficiency because that normal function, that's what happens. Is that passing through or is that... Yeah, okay. Viral infections, you know, hepatitis, HIV, that virus gets into the cell and it takes it over. And it says to that cell, hey, start making more virus, okay? So now, instead of having normal function, if we talk about, you know, viral infection of the liver, now those hepatocytes are not pumping out good stuff that, you know, hepatocytes do. It's starting to pump out viral proteins. Okay, so viruses take over for those cells. Okay, so deficiency. Now, excuse me, intoxication. So intoxication is going to be the introduction of a substance that is harmful that can either be from the external environment, and bang, you know, when we think external environment, we think of a ton of things, right? What would be some exogenous toxins or things that we get from the external environment? Okay, absolutely alcohol. I'm joking about that, but at high levels, okay, that would be intoxication because at high levels it damages the liver. So we're looking at cell damage from that. What else would be from intoxication? You could just rattle them off, right? Carbon monoxide, is that what you said? That's exactly what popped into my head. Isn't that funny before you said it? Okay, what would be another? Medications, right? If somebody takes medications improperly or is trying to overdose, that would be intoxication. Chemicals, right? Environment. Yep,
from dump sites or
absolutely. From, we just went through Syracuse. Why were we in Syracuse? Oh, we dropped my son off at college on Friday. And we were driving through Syracuse, and I was thinking, how sad is it with that lake? Because they put, do you guys know that that lake is one of the dirtiest lakes in the country, I believe. Because they let an industry set up on the lake, and what they do? Was it carbon tetrachloride? I forget what they were dumping. Yeah, oh yeah, it's in the lake. Never, ever, ever go in that lake. Which is weird because then a few miles away is Skinny-Aldalis, that's one of the cleanest in the state. But, you know, so there's an exogenous toxin, anything you could think of. Now, endogenous toxins are a little bit more difficult to think of because this is going to be things that happen inside of our body that become toxic to us, okay? So if we think about the example that I gave here is free radicals. If you go out and you spend too much time in the sun, or if you decide to take multiple x-rays of yourself or CAT scans or whatever, your body is bombarded with what's called ionizing radiation, okay? Now what happens with this is that ionizing radiation comes in and it attacks the cell, basically. And when it attacks that cell will release an ion, okay, negatively charged ion. And then that negatively charged ion will start to steal from other cells and create other deformities. That's the real basic gist of free radicals, okay? And so that starts a series of what are called free radicals in the body. Now, if the body doesn't stop that, what can happen with free radicals, okay? They're a charged particle that's unstable. It can keep perpetuating more unstable ions. Is this getting too in-depth? People are starting to glaze a little bit.
you're going to develop a change in the cell. And the
Exactly.
cell's gonna grow.
Exactly. These cells eventually, if the body doesn't reel that process in, can start to change their DNA. And if you start to change their DNA or damage the DNA, I should say, you could start to get changes in that cell, and we start the process called cancer, okay? So ionizing radiation creates free radicals, which changes the cells, which creates abnormal cells, which creates cancer, excuse me, okay? How do we stop that? We take nobody? Antioxidants, okay? Antioxidants will come in and attach to this unstable atom's charged particle, okay, and stop that perpetuation of that cycle. It's really good to take antioxidants, okay? Vitamin A, I always remember it as ACEs. Vitamin A, C, E, and selenium are great antioxidants, but they also talk now about those phytonutrients. I'll write it up here. And your phytonutrients are in your berries, your strawberries, your blueberries, your red wine, resveratrol, okay? Dark green leafy vegetables. The more you eat of those, the more they will intercept and sort of sap up these sort of rogue ions and stop them from causing damage to future cells. Okay, does that make sense? Yep. Okay, so endogenous toxins actually are going to be, even though that ionizer radiation starts it, this will be a change in the cell that creates sort of like a toxic material to our body. Okay. Any questions on that? No. Okay, good. So trauma, this is pretty straightforward, right? Hypothermia, hypothermia, extreme pressure, okay? What's gonna happen with extreme pressure? It's gonna break the cells open up all those substances inside the cell to the external environment. Oh, there's actually one more thing I wanted to talk to you about. Okay, we're on the trauma slide for people at home. What did I want to, lysosomes. So there's these little packets inside the cell called lysozymes. Whoops. Okay, little packets within the cell called lysozymes. They sort of have multiple functions. These lysozymes are waiting for substances that are not normal for that cell. So if that cell ingests a substance that's detrimental to it, the lysozyme will kind of walk over, adhere to it, open up, and dumps enzymes that'll break it apart, okay? So lysozymes do that. Lysozymes will also, do we think we create cells and then they stay the same forever? Or what do we do? No, those cells die, or they'll regenerate, because we have some cells that don't die off and get new ones, okay? They either die or get regenerated. And guess what the lysozymes help to do? Oh, some junk in the cell, I'm gonna walk over there and attach to it and eat it up, okay? So they will absorb, or I should say break down substances that have been ingested into the cell that are detrimental, or they'll eat up parts of the cell that are not needed anymore. Okay, so lysozymes are important. But the reason I wanted to go back and talk about that is if you have extreme pressure, guess what happens? You burst that cell open and those enzymes can leak out into the surrounding tissue and cause tissue damage. Okay? So extreme pressure, burns is obvious. Bacteria, viruses, okay? The viruses we talked about, that viral protein, okay? A virus will get into a cell and take over and start excreting viral proteins, okay? Any questions? I'm kind of buzzing through this one because I think this one's more self-explanatory. Any questions about this one? Okay. All right, good. So guess the cell injury. Did I go through all? I did. Cool. It's your turn. Okay, my people at home or people watching the video, I'm going to zoom you in on the PowerPoint because now it's time for you guys to work because I'm not going to work the whole class. I'm going to give you about 5 minutes to work in groups. I want you to read through these questions. Look at these questions, and from the previous 3 slides, intoxication, deficiency, and trauma, try to determine which injury would cause what I have on the screen here. So emphysema that's been destroyed by lung tissue. What type of cell injury from what we just talked about would cause this? Could there be more than one answer? Do you think? Yeah, absolutely. Okay, just want you to think about it a little bit. Okay, so I'll give you about 5 minutes to work on that. And you can work on it in groups. People at home, I'm going to zoom you in for now. There we go. Is it warm in here or is it me? It's warm, okay. That's what I thought, especially for you with that tie. Oh no, would it be deficiency, intoxication, or trauma? Yeah, and it could be primary or secondary deficiency, right? Okay, so you want to make sure you're picking from those 3 we just talked about. Intoxication, deficiency, or trauma for both the first and the second answer, right? Okay, for the first and the second. So what type of cell injury is this? You'd pick one of those 3s. What other pathophysiologies could this cause? I think more what I'm looking for with that, I'm sorry, is the effect of that disease process. So do the best that you can, okay? Do the best that you can. Does anybody else need any handouts, syllabus, or the class notes? You do? You need it? Oh, oh no, I over prepared. How are we doing? Good, yeah. Just trying to get you to think about it a little bit, okay? Just trying to get you to think about it a little bit. So let's talk about this. We may not be done, but I want to start moving ahead because I want to make sure we get through chapter 1. I think it's so helpful to review material and then think about it a little bit, okay? So I try to do that as best as I can through this class. So guess the cell injury. Emphysema that has destroyed the lung tissue. We understand that pathophysiology, right? Okay. So emphysema has destroyed lung tissue. We don't have those nice little grape-like clusters of alveoli anymore. Those membranes between them have broken open. Now we have bigger pockets of air, right, within the lungs. So emphysema. What type of cell injury caused this? Most likely, probably not inherited, right? Smoking, which would be a intoxication, absolutely. What other pathophysiologies could this cause? What secondary effects could it have? Lack of oxygen, right? So a deficiency, okay? Anorexia, what type of cell injury does this cause? Deficiency, okay? Primary deficiency, absolutely. I wonder if it would be considered secondary to, the anorexia with cancer. Yeah, that would be I would call that a secondary. Sometimes the medication. One of the theories that I've heard about anorexia with cancer is the loss of smell. So you lose your appetite. Okay, is one of the theories I've heard as well. And what other pathophysiologies could this cause? What do you think about that? That's a hard one. Lack of absorption. Right. Absolutely. Right. Apoptosis of the kidneys. Absolutely. Very good. Radiation burns from therapy would be what's left? Trauma, right? So trauma. Okay. What other pathophysiologies could this cause? Breakdown of tissues. Yeah, and I would also say maybe some deficiency, right? Losing fluids, electrolytes. Okay, good. Any questions on that? Very good. Okay, let's move on. So, looking at cell injury effects and responses. So we have reversible changes, which obviously what can happen? The cell can fix itself and go back. Irreversible is not looking good. Irreversible, I should say, is not looking good, right? Irreversible is going to mean it's it for this cell, right? Okay, so reversible versus irreversible. telling everybody. You know what? I'm going to take a break before we do this because I've been taping for 50 minutes, and let's get up and move around for 5 minutes. I'm going to stop the tape, check my emails, and then we'll start up for the second half. All right? Let me see if I have any other songs loaded. I don't. Okay. Here we go. That's funny. Let's see. There. Turn that video down. Meditation break. That's not loud. Okay, good. Yes.
The textbook, you got it online?
You could get it through Amazon. The bookstore can't carry it anymore because it's out of print. So
Like $89 on Amazon.
on Amazon.
But you're saying that for $5?
Which one did you see? Yeah, I just got the textbook.
Get more than one, so
And tell them
Holy crap. You know,
I didn't know Amazon sold that cheap. $5?
No, she said she got lucky.
I got lucky.
So it's the store.
I got really lucky.
Is it in good condition? Pretty good condition?
It's the one I'm gonna put in the class. So you guys could also use the one I'm gonna put on reserve. It's up to you.
Have like at home too, you know?
It what?
I say it's good to have at home.
Well, I gotta stop the tape.